Hi, in this video I'm going to show you how to solve an application of differentiation. And in this case, this is an example on how we can use differentiation on distance, velocity, and acceleration problem. So it says in the problem, the position of the particle is given by the equation s is equal to f of t, is a function of time, equals t cubed minus 9t squared plus 24t, where t is measured in seconds and s in meters. The first question is, what is the velocity after 4 seconds? The second question is, when is a particle at rest? And letter C, find the acceleration after 6 seconds. So, in order for you to answer these questions, you have to know the relationship of the velocity, the distance, and the acceleration in terms of differentiation or derivative. So basically, the velocity is just the derivative of the position function. So we can note v is equal to f prime of t. So if we want to get the velocity function, we simply get the derivative of the position function. So the velocity, by the use of the rules on differentiation, this should give you 3t squared minus 18t plus 24. So if the question is asking what is the velocity after 4 seconds, that means you just have to get f of 4. And f of 4 means you change the t by 4. So just do it that way. So just put the 4 in every t and then plus 24. And then you simplify the expression, the numbers. So this is 4 squared is 16. So this is 3 times 16. 18 times 4, so that's around 72, and then plus 24. 3 times 16 is equal to 48, and then minus 72 plus 24. So don't forget how to apply the PEMDAS when you subtract or add numbers when you have 3 or more numbers together. So you work from left to right, and addition and subtraction can be done depending on which comes first from the left. So subtraction comes first, so we have to subtract 48 minus 72, and basically that's 72 minus 48 and the negative value. So that's around that's 4, and then this is 24, but you're subtracting a bigger number, so this is negative 24, and then plus 24. So this will be 0. So the velocity after 4 seconds is actually 0. So at t equals 4, the object or the particle is not moving. Okay, so take note. So velocity at 4 seconds is 0 meters per second. Now in letter B, when is the particle at rest? So the particle is at rest whenever the velocity is equal to 0. Now note that in letter A, when we solve the velocity after 4 seconds, we were able to see, or we were able to find that the velocity is 0 at 4 seconds. So one of the time that the particle will be at rest, we already know that that will be t equals 4. Okay, but how do we know this exactly? So when we want the velocity to be 0, we get the velocity function. So 3t squared minus 18t plus 24, and we want this velocity to be equal to 0. So simply solve the value of t from this quadratic equation. So you have 3t squared minus 18t plus 24 is equal to 0. So note that we can divide each term by 3, including the right hand side of the equation. So if we divide both sides actually by 3, so that means you're dividing each term by 3, and this will become t squared minus 6t plus 24 divided by 3 is equal to 8, and then this is equal to 0. So remember how to solve quadratic equations. One of the ways that you can do is to factor the quadratic expression, and this is t, and this is t. You have to find a combination of 8 and 2, so this is 4, and this is 2, I need to have a positive 8, so both of them, or the two numbers should have the same signs. But since I need a negative 6, so both of them should be negative. And this simply means if this times this is equal to 0, either the first one is 0 or the second one is 0. And this will give you times equals 4 and the time equals 2 seconds. Now the 4 seconds should be one of the answers because we already found in the first problem that the velocity will be 0 at 4. By the way, so this is just a coincidence that the letter A, when we solved the letter A, we found the velocity to be 0 at 4 seconds. But in some cases, don't expect that the two problems will have the same number or the same answer. Okay, so don't forget when you want the particle to be at rest, the velocity should be 0, and then just get the velocity function, you equate it to 0, and then you solve the quadratic equation, and then you will get the numbers. So again, the particle will be at rest, meaning the particle is not moving by the time at 2 seconds and by the time at 4 seconds. Okay, now letter C, find the acceleration after 6 seconds. So again, it's all about the relationship of the position function, the velocity function, and the acceleration function. If the velocity function is the derivative of the position function, the acceleration is the derivative of the velocity function. So go back to the velocity function that we obtained. So this is the velocity function is 3t squared minus 18t plus 24. So if you want to get the acceleration function, all you have to do is to get the second derivative, which is the derivative of the velocity. So f double prime of t. So from f prime of t, so just get the derivative again. So this is 6t minus 18. And if they ask at a particular time, that means you're solving for the acceleration at a given value t. So find the acceleration after 6 seconds. That means all I have to do is to find f prime of 6. So this is 6 times 6 minus 18. So this is 36 minus 18, and this should give you 18. So acceleration is measured. So the unit of measure is square meters per second. So that is the acceleration after 6 seconds. So a positive acceleration actually is moving in the same direction as the object. Okay, so just a recap. Key ideas would be the relationship between the velocity, the position, and the acceleration functions. Velocity is the derivative of the position function. Acceleration is the derivative of the velocity function. And whenever we want to find a particular value of an acceleration, so given that time, all you have to do is to put that number, replace the t by that number, and you will obtain what you want to get. Okay, so some words that you need to understand when it says the particle is at rest, meaning the particle is not moving. And when the particle is not moving, that means the velocity is equal to 0. So that led us to equate the velocity function to 0 because the velocity is 0. Okay, now a question here did not appear in the form of, like, say, I will ask you what is the position of the particle at a given time. So if you will be asked to find the position of the particle at a given time, then you have to go back to the position function and then replace it by whatever number is given or by whatever time is given to you. So say if I want to find the position at 5 seconds, then all I have to do is to place the 5 in each t in the function, and then I'll be able to find the position at 5 seconds. Okay, so I hope you understand how we solve this problem. There will be similar problems to this, so the idea will be the same. Okay, so that's it.